Hello again, everybody. This is Eric Sullivan. We are going to continue our conversation about some Python packages or libraries that are super useful when you're doing mathematics especially, but really just general Python programming. So we've already talked about what a library or package is. We've talked about the math library, which contains all sorts of good stuff. And in this video, we're going to talk about the Numpy library. Numpy stands for Numerical Python, right? So really the idea is this library is set up to do a lot of the mathematics that we really want to do with Python in a really streamlined and efficient way. And it stems out of this. Python lists are amazing. If you haven't watched my videos on Python lists, just go back a few videos in the playlist here, you'll find them. Let's create a list, really simple. All right, so I got the list x equals 1, 2, 3, 4, 5, 6, right? Whatever, it's just a really simple list. And what I'd like to do is I'd like to apply some sort of mathematical operation to the list. So say, for example, I wanted to do 3 times every single entry in the list. So what I'm kind of expecting out of this is 3, 6, 9, 12, etc. So let's see what happens. So I run it. Oh, well, okay. I got the list 3 times. That's actually really handy as a programming practice, but that's super confusing as a mathematical practice. That's not what I actually intended. Let's try something different. Maybe multiplication is not what I wanted, all right? So what if I add 1 to the list? What I kind of expected was 2, 3, 4, etc. Let's see, can only concatenate lists. Oh boy, okay, so plus if I added a list brackets around the 1 and did those, I would have actually added a list that contains 1 to the end of that list. So I could add another list to the end of my list, which is not what I intended. The first thing I typed was just +1. I really wanted to just add 1 entry to each thing in the list. And that just doesn't happen. Or say I wanted to square everything. Doesn't happen. Well, okay, fine. Maybe I wanted to take the sign. So let's import the math library. I mean, you can probably anticipate that this is not going to work. Let's just say I wanted to take the sign of everything. Well, it's not going to happen. So there's a good reason for this. Python lists are designed so that it's not just numbers inside. I could have a list where it was a bunch of numbers, some names, whatever, a bunch of things in there, right? This is a perfectly good Python list. There's nothing wrong with it whatsoever, but doing math on it makes no sense. So what we need instead is a library that allows us to do math to lists, right? And that is the Numpy library. Now, the Numpy library does other things too. Oops. All right, so the convention when you import NumPy is to import it with the prefix NP. Now, NP is just going to be the nickname that we use for NumPy. So I can have, well, okay, it doesn't have a thing called a list. I have lots of different options for NP dot, right? I've got all the different things I could do with NP, and I can apply these to lists. I can apply them to single numbers. NP stands for Numerical Python, and this list is just ridiculously long, right? It's absurd. A couple of them that you're going to like here, though. So I've got, like, let's say an A range or a range, right? This is start, stop, and step. This is the same thing as the range that we had before. So if I went from 1 to 7, that's the list that I had before, but now I can do things like square every single entry. Or I could do things like take a sign of every single entry, and I have no idea what these signs are, right? Or I could take 3 times every single entry, and it's not just going to take the list 3 different times, it's actually going to take 3 times every entry in the list. So the initial impetus for wanting to do something with NumPy or over Python lists is that it does mathematical operations to lists in really convenient ways. But that's not the only reason. There's several handy tools that we have that come along with NumPy that we're going to use fairly frequently. So arrange you actually have seen just now. So np.arrange, open a parenthesis, start, stop, and step. This is the same thing as range, but it gives you a list of numbers that you can then do math to. So if I did 0, 10 by 0.1 and ran it, it gives me a list from 0 up to 9.9, because remember, it does not do the last one. So if I did 10.1, 0 up to 10, by 0.1s, and now I can do mathematical operations to it. All right, whatever. I'm going to square everything and add the entry back to itself. So this is kind of like applying the function x squared plus x to the entire list. And it just works. It works perfectly. Okay, so arrange is quite beautiful, quite simple. It's a nice little tool. Linspace is another one that's actually quite nice. Let me add some code here. Okay, Linspace. So this is start, stop, and number. Now what it does is it gives you an evenly spaced list of numbers over the specified interval where it actually hits the last one. So if I did 0, 10, and I said, let's do 50 of those. Or let's do 51 of, no, let's do fewer just for the sake of this example. Let's do 11 of them. So what this gives me, let's print it, is a list of evenly spaced numbers that starts literally at the starting number, ends exactly at the ending number, and has exactly 11 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers, and these are evenly spaced. If I did 10 of them, for example, now it's given me 10 numbers that are evenly spaced, and the spacing is 1 1/9. Okay, if I did 20 or 21 numbers here, it's going to go by spaces of a half. So Linspace is really, really handy if you want to absolutely ensure that you hit that last entry, because remember, arrange will always go one shy, or the step size shy of whatever this is. Okay, let's do another one. All right, ones is a beautiful one. Okay, now ones is return a new array of a given shape. So I'm just going to give it like 4 by 1. Oops, I should probably print it again. Made the same mistake on the previous one. My ones. Okay, so it gave me a 4 by 1 matrix of ones. If I just did a 4 here, it'll give me a list of 4 entries that's just ones. All right, now this is actually handy for several reasons. There's a cousin to this. Oop, if I could spell it right. The zeros command gives you a list of all zeros. So remember before I did something like give me a list of 0 times 10, and it gave me 10 zeros. The trouble with this is it is literally a Python list, not a NumPy list. Right? So I'm not going to be able to do math on this list once I fill it in. This guy, on the other hand, the zeros, is a NumPy list, so I can actually do math on. And then the last one I'm going to give you here, this nice handy little tool for NumPy, I'm going to say A is np.matrix, and I'm going to build a matrix. Now, a matrix actually has to be set up in kind of a convenient way. So let me type this matrix in, and then I'll show you what I did. So there's a lot of parentheses and square brackets there. Let's see what it did first. Okay, so I've built a matrix. Now this matrix has rows and columns. So a matrix is really a list of lists. And so I've got a list to start with. And in the first thing here, I have the first row is a list 1, 2, 3, end that list, comma. The next row is a list 4, 5, 6. And if I wanted another row, I would start another list 7, 8, 9. And I've got that nice 3 by 3 matrix. But now I can do things like, I could square that matrix if I wanted to, and it'll actually do matrix multiplication for you, which is wonderful. I mean, you can do scalar multiples of the matrix multiplication. You can do scalar multiplication, you can do matrix multiplication, all that stuff, if you defined it with NumPy matrices. So this is just a teaser for what NumPy can do. Remember, you can always do, I think it'll do NP. You can always do the dir command to see what's in a directory. And this is so ridiculously huge. NumPy is a monstrous library. So scrolling through here, we see all sorts of things. There's random stuff, there's powers, there's polynomials, there's polynomial fitting, ones. There's so much stuff I can't build one video on it, and there would be no reason to. Okay, so I'm going to delete that one. What I will show you those is if you go to Google, I'm just going to do NumPy help. NumPy.org has got all the reference that you could ever want, and there's all sorts of really good stuff here. So it's got sorting, it's got arrays, it's got universal operations, etc., etc. Go here and just hunt around, and you can find the mathematical operations that you want. We're going to use NumPy a lot because it allows you to do really efficient math on lots of things all at once. So, see me in the next video for the next library.